Hello, honorable judges and everyone. I am Mahartika from Universitas Negeri Malang, Indonesia.
Hello, I'm Diniya from Universitas Pendidikan Indonesia.
We are delighted to introduce our innovation projects entitled Lontiok Airflow. Through this project, we aim to connect culture, science, and technology in a meaningful learning experience for students. Lontiok Airflow is a multilingual digital book that integrates computational fluid dynamics or CFD simulation and local wisdom for learning airflow and Bernoulli's principle. This project inspired by Rumah Lontiok, a traditional Riau Malay house that represents cultural heritage, climate-responsive architecture, natural ventilation, and passive cooling. This project responds to two important challenges, an educational challenge and environmental challenge. In science learning, fluid dynamic concepts such as airflow pressure difference and Bernoulli's principle are often difficult for students because they are abstract, mathematical, and invisible to the naked eye. Students may know formulas, but they often find it difficult to understand how air actually moves through a building. At the same time, climate change and rising energy demand require us to think about more sustainable house design, especially in tropical regions. Many homes still depend heavily on fans and air conditioner to achieve thermal comfort. This condition increases household energy consumption and makes passive cooling strategies increasingly important. Lontiok traditional house offers meaningful local wisdom for this issue. Its right structure, roof form, shaded terrace, ventilation openings, and spatial arrangement show how traditional house can respond to tropical climate conditions. By using CFD simulation, students can visualize how air enters, circulates, and exits the house. They can also learn how the position of ventilation, windows, doors, and the main entrance affect indoor comfort. In this way, Lontiok House becomes not only a cultural heritage object, but also a scientific model for learning airflow, Bernoulli's principle, passive cooling, and even energy-efficient house design. Lontiok Airflow is our proposed innovation in science education. It is a multilingual digital book available in Malay, Indonesian, and English. The product combines three main ideas: local wisdom, CFD simulation, and design-based learning, especially place-based education. Through the digital book, students do not only read learning materials, but also explore cultural values, observe airflow visualization, and apply their knowledge in a design task. The local context is Lontiok traditional house. Students learn how its architectural elements support natural airflow and thermal comfort. Then, CFD simulation helps them see airflow patterns that are normally invisible. Finally, students use the concept to design a house prototype inspired by Rumah Lontiok. This innovation is expected to make science learning more contextual, visual, multilingual, and culturally meaningful.
First, students will directly observe the traditional Lontiok house. During the observation, the students not only just study, but they also asked to sketch of the Lontiok house floor plans. They will ask to sketch like how many openings, like doors, how many windows, and their sizes. And they also ask to sketch the shape of the roof. Not only sketch the Lontiok house floor plans, but the students will be asked to draw their own house floor plan to comparison with the Lontiok traditional house floor plan. Second, the students will use the computational fluid dynamics, or we call it CFD simulation. It can help students to stimulate about the airflow inside the house. The students will observe how the airflow through each room, each openings, and how it affects the inside thermal condition. Not only observe, students also investigate about how the percentage, the number, and the position of openings can influence the airflow inside the Lontiok house. After that, the students will compare about how the airflow through inside their own house and the Lontiok house. Third, students will explore more deeply about the scientific concept and the local wisdom that applied in Lontiok house. And the students can compare about the scientific concept, especially in airflow inside the Lontiok house and their own house, by reading from the multilingual digital book. Finally, the students will apply their understanding about the fluid dynamics, especially in airflow conditions and the thermal conditions, to redesign a house prototype. They will redesign a more energy-efficient house by implementing what they have learned. And after that, the students will stimulate about the airflow inside the house by using the computational fluid dynamics. In this stage, the students are encouraged to implement their scientific concept and local wisdom to redesign a more energy efficient of a house. And here it is, our prototype project, Lontiok Airflow, a multilingual digital book that integrates computational fluid dynamics and local wisdom. Lontiok Airflow, a multilingual digital book, is not only presents some materials about fluid dynamics, but it also presents some activities that support it with computational fluid dynamics that can be done by the user of the students. Look, this is our sample of the modern house plan and the computational fluid dynamics evidence. The sample design is a modern house prototype inspired by Lontiok Melayu Real traditional house. It's not intended to fully replicate the traditional house, but to adapt its core principles for contemporary learning and sustainable design. The house plan includes several passive cooling elements. Look at the front of the house. We have a design, the front terrace, or we call it salasar, and it functions as a shaded transition space, helping to reduce heat before air enters the indoor area. The inner core creates a small microclimate and supports air circulation in the center of the house. Openings on selected sites support cross ventilation, while upper ventilation or clerestory openings allow warm air to rise and exit from the building. Through this design, students can study how the placement of the windows, doors, ventilation openings, and the main entrance can influence airflow direction and indoor comfort. They can compare airflow before and after design changes, making the learning process more investigative. The computational fluid dynamics visualization provides scientific evidence. It makes airflow patterns visible and helps students observe velocity distribution, air movement, and pressure-related effects. This visualization becomes the bridge between traditional architecture and scientific reasoning. By connecting the sample house plan with computational fluid dynamics simulation, students can understand that local wisdom can be studied scientifically and applied to solve modern environmental problems, especially the need for cooler and more energy-efficient homes in tropical regions. We expect Lontiok Airflow multilingual digital book can generate both educational and cultural impact. First, it supports contextual science learning because students can learn fluid concepts through real local examples, not only through abstract formulas. Second, it contributes to cultural preservation. Students are introduced to Lontiok Melayu Real traditional house as an important architectural heritage that contains a local wisdom about climate-responsive living. Third, it strengthens digital and scientific literacy. Students use digital materials and computational fluid dynamics visualization to observe, interpret, and communicate scientific phenomena. Fourth, it develops sustainable design awareness. Students learn how passive cooling, natural ventilation, shading, and spatial arrangement can reduce the dependence on mechanical cooling system. Fifth, it encourages creativity and students' problem-solving competences. Students apply science and local wisdom to design a meaningful solution for thermal comfort and energy efficiency. Finally, we believe that our project, Lontiok Airflows, a multilingual digital book, become a powerful source for science learning. At this present, our project has reached the development stages. The computational fluid dynamics samples and a sample of house plan that implemented that integrating with local wisdoms, scientific concepts, and computational fluid dynamics are also available. Thank you very much for your attention and bye-bye.